$77,000 per engine, 600 horsepower of pure innovation. And for 2 years, owners watched their dream machines fail, steering gone, engines in limp mode, boats drifting helpless miles from shore. Mercury had a problem, a big one, but instead of press conferences and apologies, they went silent. And then, without a single announcement, without a single headline, they changed everything. New sensors, new seals, and a software update so advanced, it transformed the V12 into something the original engineers never imagined. The question is, what exactly did they fix? And why didn't they want anyone to know? On February 11, 2021, something extraordinary happened on a private lake in Central Florida. Lake X, Mercury Marine's legendary testing facility, had hosted countless secret engine trials over the decades. But this day was different. A select group of marine journalists had been summoned to witness what the company called the most ambitious outboard engine ever built. 6 boats lined the dock. Not small fishing vessels or weekend runabouts. These were massive machines. Center consoles and sport yachts stretching from 42 to 54 feet. And bolted to their transoms sat engines unlike anything the industry had ever seen. The Mercury V12 600 Verado. To understand why this mattered, you need to understand what came before. For years, boat builders had been locked in an arms race. Center consoles grew longer, hulls got heavier, and to push these floating giants through the water, manufacturers simply added more engines. 4 outboards became 5. 5 became 6. Some boats looked like porcupines, bristling with horsepower. It was effective. It was also absurd. Mercury's answer was elegantly simple in concept and staggeringly complex in execution. Instead of adding more engines, they built a bigger one. But bigger doesn't begin to describe what their engineers achieved. The V12 600 packed a 7.6-liter powerhead, 12 cylinders arranged in a narrow 64-degree V configuration. To put that in perspective, it displaced more volume than most pickup truck engines. Yet Mercury somehow crammed all that power into a footprint only slightly larger than their existing V8 outboards. But displacement was just the beginning. The engine featured the marine industry's first 2-speed automatic transmission, developed in partnership with AZF, the German company renowned for building transmissions for everything from BMWs to supercars. First gear delivered a 2.97:1 ratio, providing massive torque to muscle-heavy boats onto plane. Once the load lightened, the transmission seamlessly shifted to second gear at 250:1, optimizing efficiency for cruise. The shift happened so smoothly that most operators never felt it. Then there was the steering. And this is where Mercury truly broke new ground. Traditional outboards pivot on the transom. The entire engine, powerhead, midsection, lower unit, swings left and right as the captain turns the wheel. It works, but with an engine weighing over 1,200 pounds, that's a lot of mass in motion. Mercury's engineers reimagined the entire concept. On the V12 600, the powerhead and midsection remained stationary. Only the lower unit pivots, controlled by electro-hydraulic actuators hidden beneath the cowling. The result resembled pod drive technology from the inboard world, but with the versatility of an outboard that could be tilted completely out of the water. This steerable gear case could swing 45 degrees in either direction, 15 degrees more than conventional outboards. For boats using joystick docking systems, this meant unprecedented maneuverability. Below the waterline, contra-rotating dual propellers completed the package, a 4-blade prop in front and a 3-blade prop behind, spinning in opposite directions. This configuration eliminated torque steer, improved reverse authority, and delivered what Mercury called unmatched bite in the water. The price tag matched the ambition, $77,000 per engine. With rigging, joystick controls, and installation, a typical twin setup approached $200,000. Triples and quads pushed well past $300,000, yet buyers lined up. Boat manufacturers scrambled to redesign their flagships around the new power plant. Formula Boats unveiled their 500 Supersport crossover with quad V12s, 2,400 horsepower pushing nearly 24 tons of fiberglass to 69 miles per hour. Boston Whaler fitted their 420 Outrage with 600s, replacing the previous quad-engine configuration. The future had arrived. Or so everyone believed. The first reports trickled in quietly. A forum post here, a mechanic's observation there. In the months following the V12's triumphant debut, scattered owners began describing something troubling. Their engines were entering a mode Mercury called Guardian, a protective state that reduced power and limited steering capability. At first, these seemed like isolated incidents, teething problems with revolutionary technology. Every new engine platform experiences early glitches. The Verado line itself had faced challenges when it launched back in 2004. Growing pains were expected, but as 2022 turned to 2023, patterns emerged that couldn't be dismissed. The steering sensors were failing. Mercury's steerable gear case, that elegant solution to pivoting 1,200 pounds of engine, relied on position sensors to tell the computer exactly where the lower unit was pointing. When these sensors malfunctioned, the engine had no choice but to protect itself. Guardian mode engaged, power dropped, steering became limited, and boats that cost more than most houses sat helpless on the water. Forum threads grew longer. Owners shared fault codes like secret passwords, 353923, 415423, 10346. Each number represented another day at the dock, another call to the dealer, another conversation with Mercury's technical support. The problems extended beyond sensors. Steering housing seals, the barriers separating the pivoting gear case from the stationary midsection, began weeping oil. Some owners reported finding their cowlings coated with lubricant. Others worried about water intrusion into critical components. The engineering that made the steerable gear case possible also created potential failure points that traditional outboards simply didn't have. Then came reports that sent chills through the boating community. On boats with multiple V12 engines mounted at Mercury's recommended 27-inch centers, a steering malfunction could cause adjacent lower units to collide. The props themselves could touch. One owner on a prominent boating forum posted photographs of deformed propeller blades, clear evidence that his center and starboard engines had made contact underwater. The math was unforgiving. At full 45-degree deflection, a V12's prop shaft could swing more than 17 inches from centerline. With engines mounted just 27 inches apart, there was precious little margin for error if the steering system lost its electronic mind. In August 2023, government agencies in the United Kingdom and Australia formally published recall notices. The language was clinical, but the message was clear. Mercury's flagship outboard had a safety defect. The recall documentation stated that affected engines could experience steering position sensor malfunctions. When this occurred, the vessel's steering and available thrust would be limited. The corrective action required replacing the sensors and updating the propulsion software. For owners who had invested hundreds of thousands of dollars in V12-powered boats, the recall confirmed what they already suspected. Something was fundamentally wrong. The stories grew darker. A twin-engine boat 70 miles offshore, both engines vapor locking simultaneously, drifting for 90 minutes before sea tow arrived. A charter captain losing 2 months of his season to repeated steering failures. A brand new Tiara with 30 hours on the clock, its middle engine throwing a rod through the block. On boating forums, the digital gathering places where owners share triumphs and troubles, frustration boiled over. Some accused Mercury of hiding the scope of the problems. Others defended the company, pointing out that every revolutionary product faces early challenges. The debates grew heated. Through it all, Mercury remained largely silent. No press conferences, no YouTube explanations, no public acknowledgement of what owners were experiencing. Recalls were processed through dealer networks. Service bulletins circulated among technicians. But to the outside world, the company that had trumpeted the V12's launch with such fanfare now seemed to have nothing to say. What owners didn't know, what almost nobody knew, was that Mercury's engineers were already deep into something far more ambitious than a simple recall. They weren't just fixing problems, they were reimagining how the V12 would think. Behind the walls of Mercury's Fond du Lac headquarters, engineers had been working around the clock. The problems were real, the complaints were valid, and the company's reputation, built over decades of outboard dominance, hung in the balance. The first wave of fixes addressed the obvious failures. Steering position sensors were redesigned. The original components had proven vulnerable to the harsh marine environment. Salt spray, humidity, temperature extremes, constant vibration. The replacement sensors incorporated improved materials and better sealing against corrosion. Every V12 that came in for recall service received these upgraded units, but Mercury's engineers understood that better sensors alone wouldn't solve the underlying challenge. The V12 steering system was extraordinarily complex. Multiple sensors, actuators, and control modules had to communicate perfectly, thousands of times per second. A single glitch in that communication chain triggered Guardian mode, so they rewrote the software. The propulsion control algorithms were updated to handle sensor anomalies more gracefully. Instead of immediately limiting power at the first sign of trouble, the system could now evaluate whether an unusual reading represented genuine danger or momentary interference. False alarms decreased. Owner confidence slowly improved. Steering housing seals were re-engineered. Wiring harnesses were rerouted to prevent pinching beneath cowlings, a simple problem that had caused disproportionate headaches. Isolator components in the electrical system received upgrades. These changes rolled out through dealer networks throughout 2023 and into 2024. Owners who brought their boats in for service left with engines that behaved more reliably. The forums grew quieter. Crisis appeared to be averted. Then, in October 2024, Mercury did something remarkable. They released a Smart Craft operating system update that fundamentally transformed what the V12 could do. Not a patch, not a bug fix, a genuine leap forward in capability. And they announced it with so little fanfare that most owners never heard about it. The centerpiece was something Mercury called slip control. Remember that revolutionary two-speed transmission? Mercury's engineers realized they could use it for far more than shifting between gears. By allowing the transmission to slip, reducing the mechanical connection between powerhead and propeller, they could achieve levels of precision impossible with traditional outboard systems. Under the new software, the V12's transmission could slip up to 90% when needed. During delicate joystick maneuvers, this meant the propellers could turn more slowly without the engine having to constantly shift in and out of gear. The results were dramatic. 25% fewer shifts during typical docking operations, 20% less heading error when using Skyhook, Mercury's digital anchoring system that holds a boat's position against wind and current. Fewer shifts meant less mechanical stress. Less mechanical stress meant longer component life. The update didn't just make the V12 easier to operate, it potentially made it more reliable. But slip control was only the beginning. The update introduced closed-loop velocity control, a system that continuously monitors how the boat actually moves through the water, not just what the engines are doing. If wind pushes the stern to starboard during a joystick maneuver, the system automatically adjusts throttle and steering to compensate. Owners reported up to 74% reduction in unwanted drift during sideways movements. Perhaps most significantly, Mercury changed how the joystick interprets driver commands. Previously, moving the joystick translated to engine RPM. Push the stick forward, engines spin faster. The problem was that identical RPM produced different actual speeds depending on wind, current, and load. Docking in a crosswind required constant adjustment. The new software works differently. Joystick input now translates to speed over ground, measured by GPS. push the stick to move sideways at 2 knots, and the system automatically adjusts throttle to deliver exactly 2 knots, regardless of what the wind is doing. The V12 had learned to think for itself. To understand why the V12 experienced these problems, and why Mercury's response took the form it did, requires stepping back to examine what the company was actually attempting. Mercury wasn't simply building a larger outboard. They were inventing an entirely new category of marine propulsion. And invention, by its nature, involves walking into darkness. The steerable gear case presented the most formidable engineering challenge. Pod drives, inboard systems where only the lower unit pivots, had existed for years. Volvo's IPS and Mercury's own Zeus systems brought joystick control to the sterndrive world. But these systems lived permanently underwater, protected by the hull above them. An outboard is different. It gets tilted up and down. It gets trailered across highways. It gets pressure washed after saltwater use. The pivot point between powerhead and gear case had to withstand forces that pod drives never face, while maintaining the same precision and reliability. The engineers who designed the original pivot seals weren't incompetent. They were solving a problem nobody had solved before. And the ocean, as countless mariners have learned, finds every weakness eventually. The 2-speed transmission represented another calculated risk. ZF builds some of the finest gearboxes in the world. Their transmissions power everything from family sedans to exotic supercars. But automotive transmissions operate in controlled environments. Stable temperatures, predictable loads, regular service intervals. Marine transmissions face a different reality. Salt-laden air, constant humidity, temperature swings from freezing mornings to scorching afternoons, load conditions that change every second as waves lift and drop the hull. Mercury and ZF had to adapt automotive excellence to maritime brutality. The learning curve proved steeper than either company anticipated. Then there was the integration complexity. Perhaps the least visible challenge, and the most consequential. The V12 isn't just an engine, it's a networked system. Steering sensors talk to throttle controllers. Throttle controllers talk to the transmission. The transmission talks to the gear case actuators. Multiple engines must coordinate their movements through the joystick system. GPS positioning feeds into skyhook calculations. Everything connects to everything else. In such systems, reliability mathematics work against you. If each individual component achieves 99% reliability, a system with dozens of components will fail far more often than any single part. The V12 had more potential failure points than any outboard before it. Some of those points failed. Mercury's decision to handle the crisis quietly was strategic and remains controversial. The case for silence had business logic. Voluntary recalls demonstrate responsibility. Fixing problems through dealer networks keeps messaging controlled. Boat manufacturers who had committed their flagship models to V12 power needed confidence, not headlines. And owners who never experienced problems had no reason to worry about problems they'd never encounter. The case against silence was equally compelling. Owners felt abandoned by a company that seemed unwilling to acknowledge their struggles. When Mercury didn't fill the information vacuum, forums and speculation filled it instead. Some buyers walked away from V12-powered boats entirely, not because of actual failures, but because of uncertainty. Trust, once damaged, is expensive to rebuild. Yet despite everything, the recalls, the forum complaints, the quiet admissions of imperfection, the V12-600 remains the undisputed king of high-horsepower outboards. The competitive landscape explains why. 7 Marine, which once offered engines exceeding 600 horsepower using Marinized Cadillac V8s, no longer exists. Volvo Penta acquired the company in 2017 and shuttered it 3 years later. Yamaha's F425 XTO, while excellent, delivers nearly 200 fewer horsepower. Suzuki and Honda don't compete in this stratosphere. Owners may complain about their V12s. They may vent on forums and demand better service, but they're not switching to alternatives that don't exist. Mercury's gamble on revolutionary technology created problems. It also created a monopoly for owners of V12-powered boats, and for those considering joining their ranks. The story of Mercury's quiet fix carries practical implications that deserve clear examination. If you currently own a V12 600, the most important step is confirming that your engines have received all available updates. Contact your dealer. Ask specifically whether the steering sensor recall has been completed. More importantly, ask about the October 2024 software update. Request verification that slip control and closed-loop velocity control are active on your system. These features don't just improve handling, they reduce stress on the components that caused early reliability concerns. Documentation matters more than ever. Maintain complete service records. When the time comes to sell, buyers will want proof that your engines received every fix Mercury developed. In a market still processing the V12's complicated reputation, paperwork translates directly to resale value. For prospective buyers, the landscape has shifted favorably. New 2025 installations come standard with all updates. The engines rolling off the line today incorporate lessons learned from 4 years of real-world operation. If you're purchasing used, verify the software version and demand complete service history. Consider that triple installations may offer better reliability than quads. Fewer engines mean fewer potential points of failure and more space between lower units. For skeptics who've written off the V12 entirely, history offers perspective. Every revolutionary marine engine has faced early troubles. The original Verado 300, now considered among the finest outboards ever built, experienced its own growing pains during the mid-2000s. Mercury's Optimax 2-stroke required multiple refinements before achieving its eventual reliability. Even Yamaha's bulletproof 4-strokes evolved through several generations. First-version struggles are the price of innovation. But beyond practical guidance, the V12's transformation reveals something profound about the future of marine propulsion. Mercury's software update didn't just fix problems, it laid groundwork for capabilities that would have seemed impossible a decade ago. The company's own announcement explicitly mentioned positioning the technology for autonomous boating. That phrase deserves attention. Speed-based joystick operation, where the boat maintains commanded velocity regardless of environmental forces, is identical in principle to how self-driving cars maintain lane position. Closed-loop velocity control, which automatically compensates for wind and current, mirrors the automated station-keeping systems on commercial vessels. Slip control, which precisely modulates propeller speed independent of engine RPM, enables the kind of fine motor control that autonomous systems require. The V12 isn't just an engine anymore, it's a platform, a foundation upon which Mercury can build increasingly intelligent capabilities through software alone. Today's update improves docking. Tomorrow might enable the boat to dock itself. This software-first approach represents a fundamental shift in how marine engines will evolve. Problems that once required physical redesigns, new castings, new machining, new assembly procedures, can now potentially be addressed through code. The engine you buy today may become more capable over time, not less. Mercury's silence through the V12's troubles may have frustrated owners, but it also reflected a company focused on engineering solutions rather than managing perceptions. The proof sits in the water. Boats that struggled through 2022 and 2023 now operate with systems their original buyers never imagined. There remains something almost poetic about how this story unfolded. Mercury could have issued press releases celebrating their fixes, They could have launched marketing campaigns positioning the updated V12 as a triumph of responsive engineering. Instead, they chose to let the technology speak for itself, pushing updates through dealer networks while the world's attention moved elsewhere. Whether that silence represented wisdom or missed opportunity depends on your perspective. What cannot be disputed is the outcome. The V12 600 that exists today bears the same name as the engine launched in 2021, but it thinks differently. It reacts differently. It protects itself and its operators in ways the original version could not. In an industry where new and improved usually means a fresh coat of paint and updated graphics, Mercury quietly performed something rarer. They made their most ambitious creation smarter. And they did it so subtly that most people never noticed. Perhaps that's the most remarkable engineering achievement of all.